So I'm here today to review the homework from tab 4, and so that's up on the screen. You should be able to see it. So the first question is, what is a standard heat of formation? And basically what that's asking is the enthalpy specifically of your products and your reactants at 25 degrees Celsius and 1 ATM. Um, that is the standard heat of formation. So, and we typically represent that with the letter H and a little circle up in the upper right hand corner, and I'll show you that in a minute. So, number 2 says, what is the formula for calculating the heat of a reaction? So, the formula that we're going to be doing is based off of Hess's law, and that formula is delta H of the reaction, we abbreviate it RXN, is equal to delta. So, this is the standard heat of formation, which I was talking about just a second ago. It has a little like zero above it for the superscript. And that's going to be the products minus the standard heat of formation of the reactants. And so the way we use this to calculate things is basically to tell us if a reaction is endothermic or exothermic. And so if a reaction comes out with a final answer of a positive value, then we know it's going to be an endothermic reaction. If it comes out with a negative value, it's going to be an exothermic reaction. So before I get into the next couple problems, I just want to go over chemical reactions and chemical equations. So chemical equations basically tell us what goes into a reaction, right? And so there are certain parts that you guys need to know about chemical equations. And so it always is in the form of reactants yield, that's the arrow, products. And so, for example, if I give you the equation C6H12O6 plus 6O2 yields 6CO2 plus 6H2O, then this first section is going to be your reactants. The second section is going to be your products. And there are numbers in front of some of the reactants and products, and we call those numbers coefficients. So those are all coefficients. Then there are small numbers that are also in these equations, and we call the small circled numbers, so the arrow is the coefficient, the circle is going to be our subscripts. So coefficients basically tell us the number of moles that we have, and that's going to be important when we're calculating these standard heat of formation or our enthalpy of the reaction, how much energy is in this reaction, right? Subscripts basically tell us the number of elements, right? Or the number of atoms, I should really say, not elements, atoms. Okay. And so that also brings me to the next section of vocabulary, which is atoms versus compounds. So atoms is going to be a single element. And those are those letters that you guys see that represents different substances. So like O represents oxygen. You see that one a lot. C represents carbon. Compounds, on the other hand, are going to be two or more elements put together, right? So two or more elements. So that's kind of the baseline of what you need to know in order to solve these problems. So our first problem that you can see on the left side is it's number 3 from tab 4. So I'm going to go ahead and write down number 3. It says use the standard heat of formation provided to calculate the standard heat of the reaction for the reaction between water and sulfur trioxide shown. So we have this reaction of H2O plus SO3 yields H2SO4. So this is water, this is our sulfur trioxide, and this is called sulfuric acid. So we're going to use that equation that I started everything off with, which is the delta H of our reaction, and that's going to be equal to our standard enthalpy of formation for the products minus the standard enthalpy of formation of the reactants. And I'm going to start abbreviating this as just P and R for products and reactants. So I'm going to take those values that are in the table off to the left where it says substance and then delta H formation, and the units are kilojoules per mole. So we're going to take that and we're going to have to look at our equation, our chemical equation. In front of all of these is nothing, right? And that's actually because ones are in front of those. So we have 1 mole of each of those substances. Ones in chemistry are assumed. So when I'm doing this calculation, basically I'm going to take those values from the table and then plug it in. And so that's going to look like this. I'm going to have 1 mole of my H2SO4, which has a value of negative 735.1 kilojoules per mole. And I'm going to subtract that from my reactants, which is water. So my value for water, I have 1 mole of water, and I'm going to multiply that by the value given in the table, which is negative 395.8 kilojoules per mole. I'm going to add that to the other reactant, and my other reactant is that SO3, and there's 1 mole of that times my value from the table, which is negative 735.1 kilojoules per mole. All right, so moles are going to cancel out. We're going to be left with kilojoules. And once I plug that into my calculator, the final number that I get is actually negative 97.5 kilojoules. Okay, so that's my final answer for that. The next problem number, I guess I did letters. So that was letter A. That was 3A right there. The next letter is B. Let's take a look at that. So B is telling us to use the standard heats of formation provided to calculate the standard heat of the reaction for the reaction between water and carbon dioxide shown. So we have our 4 CO2. So that again is a coefficient. 4 is our coefficient. Plus 2 H2O yields 2 C2H2 plus 5 O2. Okay. So again, I'm going to use that same reaction that I did before, and that is our delta H of the reaction is equal to our delta H of our products minus our delta H of our reactants. Okay, so same thing like before, we got to look at those coefficients. So we do have some coefficients here. So take those into consideration when we're actually multiplying everything out. So my products, I'm going to start off with that 2C2H2. And so that is going to be 2 times the value from the table, which is 226.7. So that was 2 moles times 226.7 kilojoules per mole. And then the value for oxygen is nice and easy. It's just 0. So that's an easy one. subtract that from our reactants. Our first reactant is the 4CO2. So we're going to multiply that by 4 moles times the value in the table, which is negative 393.5 kilojoules per mole. And then I'm going to add that to my other reactant, and I have 2 moles of that, so that's 2 moles times the value of H2O from the table, which is 241.8. And that's kilojoules per mole. And so moles, again, are all going to cancel out. Anytime I see a mole, it's going to cancel out. When I plug that into my calculator, my final answer is going to be 2,511.0 kilojoules. Okay. All right. So those are my first couple problems. Let me get a new page here so we can get it going. So then the last 2 problems, when we're looking at these, is letter C. Use the standard heats of formation provided to calculate the standard heat of reaction for the reaction between hydrogen sulfide and oxygen shown below. All right, so this is letter C. So let's look at this. So the equation that I'm looking at for this one, I always like to write it out, is my 2H2S, so again, coefficient, plus my 3O2 yields my 2H2O plus my 2SO2. Okay, so again, the equation that I'm using here is delta H of the reaction is equal to delta H of my products minus delta H of the reactants. Okay. And so then I'm going to look to the table for these values that I'm going to plug in. So my first product is H2O. So I'm going to do 2 moles times my value from the table, which is negative 285.8 kilojoules per mole. My second product, I'm going to add that to the first one, was 2 moles. Again, looking at those coefficients right here, that's how I'm getting that number 2. Times the value from the table for SO2, which is negative 296.8 kilojoules per mole. Okay, and I'm going to subtract that. I'm going to go on to my next line because I'm running out of room here. And that's going to be, so here's my reactants. I have 2 moles of my H2S, and that's the value from the table, times my 20.6 kilojoules per mole, plus my last reactant is oxygen, and the value from the table is 0. So that's a nice one. So again, moles are going to cancel out all throughout. We're left with kilojoules. When I plug that into my equation, I get negative 1,124 kilojoules. So that's my final answer for that one. The last one, letter D, says, which of the following heats of formation are endothermic? So when I'm looking at this problem, all I have to do is think to myself, back to remember what I said before, that anything that has a positive value is going to tell us that the reaction is going to be endothermic. And so anything that's going to have a negative value will be exothermic, right? So looking at this, my positive values are going to be the C2H2, right? And then I have C2H4. And those are the only 2 that are positive, right? So those are your 2 answers that we have there. All right, hopefully that helped.